I'm Nicole Yip. I work for the Lego Group, and I'm a senior infrastructure engineer in the direct shopper technology team. I'm going to talk to you today about my talk, so no more AWS keys for you. And we're moving our team towards best practices in terms of making it easy to acquire temporary AWS access keys. When I was coming up for the title of my talk, I was trying to hook into that protective nature of developers because it's you guys who need to hear this talk. I've encountered quite a few of you in my career, and you just want to set and forget your access keys, and then who knows what can happen to them. So a little bit about me so that I can calm down and get into the swing of things. I'm a senior infrastructure engineer. I've been working there for about 10 months now, so not too long, but I've been managing production workloads in AWS for about 4 years. Side note, I like to do bouldering, so here's me looking like a spider. And I also love to do baking. So normally the first question anyone asks me is, what do you do at the Lego Group? Do you design the bricks? Do you make models? No, I look after the shop. So www.lego.com, any part of the site where you look at products, where you check out and actually give us money, that's what my team looks after. In fact, if you haven't heard already, we recently re-platformed this shop onto being entirely serverless on AWS. We've been serverless since August 2019. It was a 1.5-year project, and we moved from the old shop.lego.com domain into becoming the landing page for www.lego.com. It took about 20 to 40 engineers, and the team flexed up and down within that time, but we got there in the end. So we now run the entire retail side of lego.com on 4 Fargate services serving our front end, backed by about 37 serverless packages that dissolve down into about 180 Lambda functions. So we've done a lot of work in 1.5 years. So enough about me, enough about what I do. I want to find out about you. So get ready to raise your hands. Which of you use AWS? Yep, most of the room. I expected that. Who uses AWS access keys? Yep, a lot of the room. Okay. Who of you have rotated them since you first received them? Oh, okay. Yeah, more than I thought, but still not everyone. So this is what this talk is about. So what's the big deal? AWS access keys protect the same level of access that your username and password does. You rotate your password every 3, 6, 12 months, right? Or at least my company makes me rotate them every 3 months. So your access keys, some of them can be years old, right? So why aren't you rotating them as often as your password? So the way that I'm structuring this talk, I'm going to go through the why is it a problem and all of that. I'll go through some AWS basics on IAM, users, groups, roles, all of that, so that we're on the same level. And then pull that over to a corporate user management perspective. Like I said, we have 20 to 40 engineers that went up and down in that time. And then everything underlying how we get the temporary access keys is federated user access, so I'll explain what that process is. We wrote a CLI tool, and so I'll show you that, and it'll be a very little fun demo. And then, yeah, if we have time for the demo. I mean, I'd rather not do it, but we'll see. So why? Why do we want to protect our AWS account? I probably don't need to spend too much time here, but you've got pay-as-you-go compute power right at your fingertips. And I mean, if someone gets into your account, there's a whole bunch of reputational damage. And when you're running a retail site, any amount of downtime is revenue lost, right? The other reason is to protect sensitive resources. So we all deal with sensitive data. I guess at the Lego Group, we've got a lot of sensitive images, so we're trying not to leak products that haven't been released yet. And then there's the usual suspects, PII, credit card data. We're all in that age of GDPR, so you need to keep people out of your AWS account that don't belong there. How does AWS help you do that? There's 2 levels of access control that they have. So there's resource level, this is your S3 bucket policies, and then there's user level. So that's the policies you put on your IAM users, your groups, and this is the one I'm going to focus on in my talk. It's the broadest one, it's got the most factors out of your control, and so that's what we're going to do. So let's go through some basics. I'm sure I don't need to spend too much time here, but Let's go to the most basic scenario. You've got a vanilla AWS account and you want to host a bucket of surprises. So the first thing AWS makes you do is create a root user. You cannot limit the privileges on this user. Good idea to put MFA on it. I should be pointing up there, I guess. And the other thing AWS recommends is you do not use the root user. In fact, you create yourself a day-to-day administrator user and then never log into root user again. There are some instances where you do need to use the root user. It used to be that if you had to tell AWS if you're doing penetration testing. I don't think that's the case anymore. But yeah, just use a day-to-day administrator. Don't log in as the root admin, no matter how tempting it is. And let's say you have a developer friend named Bob. He wants to help you put things into your bucket of surprises. So in this little scenario, you've got 2 users, and they'll be pretty easy to manage access to your AWS account, but it means you're already having to trust someone else with the keys to your kingdom, so to speak. So some basics. AWS IAM, or Identity Access Management, has about 4 basic concepts: groups, users, policies, and roles. And I'll just quickly step through them. So the first thing is users. A user is a resource that has your username, your password. If you've got any access keys, they live in that resource as well. If you've set up MFA, multi-factor authentication, that's all set up in your user as well. One thing to note is there is no way for you to expire your AWS access keys after a period of time, once it's been associated with your user. Yes, you have to log in to the console, click inactive, click delete, right? So let's say you've got 20 to 40 developers. Is that going to be feasible if they all get compromised? So that's the one problem that I'm trying to revolve around here. So policies, it's allow or deny on all AWS API calls. You can have custom lists, or you can use the AWS managed ones. You can say, I just want all the policies for administrator access, or all the policies just for CloudWatch read-only. And they can be associated with users, groups, and roles. So, talking about groups, groups are for collecting users with similar access needs and associating the required policies with those groups. And so that's the normal way that you would manage users for a small scale, for like me and my friend Bob. So I would create a group of me being an admin, him being a dev. Maybe the admin has, well, I would have rights to everything. Developer, he can just put things into S3. That's easy enough to manage. So I'll quickly walk through roles, and then I'll jump into a corporate context where this all kind of explodes. So roles are slightly different from user group policy. A role is actually a collection of policies that can be assumed by any other AWS service, users that have been authenticated outside of AWS, things like that. I think of them as a hat, so you can temporarily put them on, and then it kind of expires and you're no longer that role. So this is how we've solved our problem of people setting and forgetting their AWS access keys. Because when you assume a role, it's temporary. The role has a maximum duration that you can assume the role for. So, 2 broad ways of managing user access to your AWS account. There's the groups, users, policies, or you can have roles and policies. And so, thinking about those 2, let's go to a corporate context. In Lego's case, we wrote 180 Lambda functions that grouped themselves into 37 serverless packages. We had about 20 to 40 engineers working over 1.5 years, so we had a lot of onboarding. We also had a lot of offboarding to deal with. Not only that, those engineers needed different access to different AWS accounts. We've got an AWS account for development, acceptance, and production, 3 AWS accounts. They also needed different levels of access to those accounts. In development, maybe they had admin, so they could deploy their Lambda functions, test, and all of that. In acceptance, maybe we gave them Viewer Plus. They could have a look at what their functions were doing, and maybe they could trigger them just for out-of-cycle testing. In production, they had no access at all, but then they complained, so I gave them Viewer, but just for the services that we actually use. So they can't see EC2 because we don't use that. So let's try and use the first scenario for this. So I've got, let's say, 30 engineers. I've got 3 AWS accounts, and they need roughly 2 levels of access, administrator or developer. So I could create them all IAM users. So that's 30 users to create, put them into the correct groups, and then do that again for the other 2 AWS accounts. So that's already 90 users that I need to create. And let's say that's 3 or 4 clicks to create each one. I'm not going to try and do the maths because this is recorded and I'll be recorded saying the wrong number, but it's going to be a nightmare. Management overload. Whenever someone gets offboarded, I have to delete their user from 3 AWS accounts. Whenever I bring someone in, I have to create them a new user. They have to remember a new password. And when you give developers lots of passwords to remember, you're going to get repetition. You're going to get the same password in development as production, and that's a big no-no. Do not do that. So the other alternative is to use roles. So like I said, roles let you assume the role from a user that's authenticated outside of AWS. So in this case, we're going to use our corporate login, our Lego Active Directory services. So this means there's no additional offboarding for me. When their contract ends, they get removed from the corporate AD servers automatically. So they immediately can't access the roles that they originally had. And there's no additional passwords to remember. So you single sign on in and you're done. No more passwords, no more replication, all good. So the whole thing underlying this process is called federated user access. What is that? It's also known as single sign-on. You've probably heard of that. Essentially, it's outsourcing user authentication. So any service that doesn't, at its core, deal with users and having to authenticate them with a username or password or something else, you can just outsource it to another service that does have that at its center. So there are a couple terms that you need to know for me to explain federated user access. The first one being the user or client, so that's the person who wants to log in or the workstation on their behalf. There's a service provider, because remember, we're trying to log in to access a service, right? So the service provider is the one providing that service. And I put some shopping bags there because let's say it's a retail site. And then there's the identity provider. This is the one who has the data around the users already. They already specialize in authenticating users. So here's a real-world use case that I guess I've gone through recently, but it'll make a lot more sense. I want to access Medium because I want to write a blog. Medium says, I provide blog creation and hosting, but I don't want to manage user authentication or anything like that. So here come along Google, Facebook, and Twitter and say, we know we have lots of users. We already authenticate them. So why don't we let other applications use our sites to do the user authentication on their behalf? So yeah, that's essentially federated user access between Medium and identity and any of these identity providers. So the first thing to set up this whole process is a trust relationship needs to be established between the identity provider and the service provider. This is essentially just an exchange of metadata. In the service provider metadata, it says, when a user is successfully authenticated, send me back this data, or these details. Here's a certificate so that you know that the request is coming from me, and here's a URL so you can send the users back after they've authenticated. The identity provider metadata is a little bit more simple. It says, service provider, here's where you send your users to initiate login, and here's a certificate so that you can verify that the response I sent back actually came from me. And so that's enough to generate this trust relationship. They're now aware of where users need to be sent in order to go back and forth between them in the authentication process. So the next part is, how do you initiate login? There's 2 flavors of federated user access. There's service provider initiated or identity provider initiated. So service provider initiated is a lot nicer. It's better for public consumption because you get this nice box. So you go straight to Medium, the service you want to access, and it says, we don't do authentication, but you can use any of these accounts that you already have. So it's nice from a user perspective. Identity provider initiated login is not as nice, or at least the ways it's been implemented that I've encountered has been not as nice. It's often this weird URL that's really long and that you just bookmark and click on, and that signs on behind the scenes. But somewhere in there it says IdP Initiated Sign-On, and that goes straight to your identity provider. So in our case, our Lego AD servers, and that logs you in and sends you back to the service that you intended to access. So In our case, we're using IdP Initiated or Identity Provider Initiated Login. So our first request goes to the identity provider. But then the next question is, so what are you sending to the identity provider? A username and a password, that can't be very secure. So we use NTLM authentication, which is one step up from basic auth and seems to be a good alternative. So let's go on a little bit of a tangent. Basic auth, I'm sure you're aware, authorization header, the word basic, space, base64 encoded string, username, colon, password. Yes, it's security by obfuscation. You can't immediately tell what the password is. But anyone who sees the word basic is going to base64 decode what the next string is. NTLM is slightly different. So you send a request to your identity provider and say, hey, I want to log in using NTLM. The identity provider responds and says, okay, encrypt this. Use the password you have. So the client encrypts it, sends the encrypted string back. And then the identity provider determines if the encryption was done correctly with the correct password. If it's correct, you get logged in and you're all authenticated. And so the request comes back from the identity provider to the user client saying, okay, you were successfully authenticated. Here's all the data that you requested, that the service provider requested when we set up our trust relationship. So how does that data come back? Because it is user data, it needs to be secure. So that request that comes back is called a SAML assertion. SAML is security assertion markup language. And it's a standard for communicating successful authentication responses between parties. So it includes things like session details, how long you are allowed to be how long you're recognized as being authenticated for, and some other user details that the service provider has requested. So it could be your name, email, any other things that the identity provider already has on you. And yeah, so that list is configured when the trust relationship was initially set up. So on a successful authentication, you get the SAML assertion back. This is then passed to, I've got animations. This is then passed to the service provider, who validates that it's got the right certificate, that it did legitimately come from the right identity provider, and then takes that information, creates you a session in their own service, and allows you through. You can now write your blog on Medium. So what does that look like? What does that look like for Lego? Our identity provider is our AD servers, and our service provider is AWS, because all I'm trying to do is log into AWS. I want to deploy something. So out of the box, an Active Directory service doesn't have federated identity management capabilities. So we normally configure or deploy or add in the federated identity manager layer. The ones that I've come across in my career have normally been ADFS. If you read any AWS documentation, ADFS is kind of the preferred. All the documentation is around it. I've also come across Tivoli, and I'm sure there's heaps out there, but it's just another layer that provides that IdP initiated URL that I was showing before. So let's just walk through the process again, because I think repetition helps with remembering. So we send the NTLM or login request to our AD servers. We get a SAML assertion back from our AD server to the user/client. And then we make this call to AWS STS. This is AWS's security token service. So this is the service that gives us the temporary AWS credentials. And I couldn't define it any better myself than AWS. So here's the first line in their AWS STS documentation. AWS STS Security Token Service is a web service that enables you to request temporary, limited privilege credentials for AWS IAM users or users that you authenticate yourself, so federated users, and that's our case. With AWS STS, there's 3 different methods you can use. The first is assume role, and this is normally for cross-account access. So if my IAM user is allowed to assume a role in another AWS account, then you can just STS assume role, and that gives me access to another AWS account with an existing IAM user. The second one, which is the one that I'm going to walk through with my scenario, is assume role with SAML, because we're getting a SAML assertion back, so we just send it across to AWS. The last one, just for completeness, is assume role with web identity. So this is users authenticated with Cognito, Facebook, Google, anything that conforms with the OpenID Connect standard. But like I said before, we're going to focus on assume role with SAML. So that's the once we've taken the SAML assertion, we've selected the role we want, we send the AWS STS assume role with SAML call to AWS. AWS then says, okay, you want this role, you want your session to last this long, here's some AWS access keys and a session token. One thing to keep in mind is the amount of time your keys are valid for is a combination of the maximum time that you've configured in the role in AWS and the duration that you've requested in the AWS STS assume role with SAML call. So it's the larger of the two. Smaller? Smaller of the two. that makes sense. But that's a lot of calls, right? I mean, or is it? Because a lot of that happens in the background. So there's two ways you would go through this flow. The first one is if you go through a browser, and the second is if you go through a command line, through the command line, I should say. So I've got some screenshots for the browser flow, because it's actually fairly straightforward. So you go to the IdP Initiated URL, you get displayed with a nice list of all the roles you have access to based on the AD groups that you're in. I think this is a little application that AWS sends back, because it always looks the same. So you select the role that you want to assume, you click sign in, and hey presto, you're in the AWS console. And you've got the permissions that the role you selected has as its policy bundle. So for command line access, we wrote a tool. It's not a new tool, because AWS has their own. But theirs is written in Python. So all of our developers are in Node.js. So we just rewrote our own version in Node.js and made it look really pretty. What else do I need to say here? Oh yeah, so we rewrote it as in Node. We published it as an npm module to our private GitHub package repository, and now our developers just have to npm install -g Octane CLI. And now they have this CLI tool that they can enter in their credentials and get these temporary AWS tokens and no longer need to have their set and forget AWS access keys. Now, based on my explanation before, this should all make sense. The first thing we do is log into ADFS. So that's take your username, password, initiate the NTLM login. We then receive a SAML assertion back. And within the SAML assertion is a list of roles that you are allowed to assume based on the AD groups that you're in. You then select the role that you want to assume, and then we send a request off to AWS, which is the AWS STS assume role call. The access keys that then come back then get stored in your default AWS CLI profile, and you're done. You can make AWS CLI calls. So what does this look like? Because I said it looked pretty. So you get prompted for your username and password, and then you get a response back saying, yes, you logged in successfully, here's the list of roles. We then split the roles by AWS account, so you select what environment you want to access first, and then if you have multiple roles within that account, then you get that list as well. And then once you've done your selection, we send it off to AWS, and it says, yep, all good. We've stored your access key and secret in your default profile. It's good to note that we also added in 2 switches to modify this behavior. So the first is session duration. By default, you get a 1-hour session back, but I think we've configured our role all the way up to 8 hours, so you can have an 8-hour working day without being interrupted and your keys expiring, but it's still within the day, so I think that's all right. The second thing that we added was the profile. So some people still use your profile to separate keys between different AWS accounts, and I think that's left over a bit from having permanent set and forget keys, but we made a concession. We said, okay, you can store these keys in any profile you want. By default, it's default, but you can tell us what you want to call it. So, unfortunately, I'm ahead of time, which means I probably have to do the demo. So, okay, here we go. Let's open my terminal and put it on the screen. Oh, that's not it. I think that was my home directory. Command Shift plus. That's probably big enough. All right. So for this, I need to be on the VPN, which I think I am. So actually, let's prove I don't have any keys. So AWS EC2 describe instances. Spelling. Oh, nope, didn't work. So let me get some tokens. Octane login. So side note, Octane is the name of our main mono repo, so that's why the CLI is called Octane. My username, my password that I won't read out. All right, so I have access to a lot of AWS accounts because I'm an admin. So let's go to Playground. And let's do viewer, because you only use admin if you're making changes. Logging into AWS, successful, successful. And let's run the same thing again. Hey, I hope you weren't expecting a result because we're serverless, remember? All right, back to the presentation. That was my brief foray into a live demo. And I've lost my mouse. Oh no. I can't get it off the screen. Oh, there it is. Goodbye. So, let me start this. Seamless. All right, let's summarize this. AWS access keys are secrets. They protect the same level of access that your username and password protect. So keep them secret. Don't put them into GitHub. Don't put them into any place that's public. AWS IAM users equal maintenance. For small-scale projects, yes, that's fine. You can, if you're managing one AWS account, all good. 3 AWS accounts, 9 AWS accounts, becoming a bit of a problem. Access keys issued to IAM users do not expire after X amount of time. And this is for a good reason. I mean, they are actually used as service account keys, so often you set them onto a remote server, and sometimes you lose access to that server, but it still needs to be working in production. So there is a reason for it, but still not good for developers that tend to commit code to all sorts of places. Assuming an AWS role issues temporary AWS access keys. Ding. Identity federation is the underlying process that enables us to do what we do. The identity provider has user data, and so they can do the user authentication, and the service provider is the service you're trying to access. And identity federation, like I said, ties it all together. It means we can use our corporate login details to assume an AWS role and receive temporary AWS keys. No more personal access keys that last forever. Woo! And so, little side note, our Node.js CLI tool makes requesting these access keys really easy because it wouldn't be adopted any other way, right? That's me, cool bananas. My name's Nicole Yip, follow me on Twitter. And we have a Lego engineering medium organization. I don't know what it's called. But we post blogs up there every now and then about cool things we do. And I'm turning this talk into a blog post. So if you don't get the slides, if you don't watch the recording, you can at least read the blog post about it. So yeah, I think I'll be taking questions if there are any. But thank you for listening. I'll stop hiding and wander out over here.
Have you thought about putting an MFA into the mix?
Yes, actually. So now that we've delegated user authentication to our corporate servers, it's now up to them to enforce MFA on everyone who logs in. They came back with a response that said, so I asked them 2 or 3 weeks ago. They came back with a response saying, we could put MFA, but that means even when you use your CLI tool, you have to have MFA, and it applies to the whole organization. So I think some other teams in Lego are also doing this, the federated access, and so they don't want to impose it on everyone just yet until they get a gauge of how people are using it. But they said they can put MFA on the root user, which I thought they should be doing already. One question? Okay. I hope you're all going to delete your AWS access keys soon. All right, I've given you 10 minutes back in your day, I think. Speedy talk.